Example 2. Application to geometry. Classic stuff. So a farmer wants to enclose a penned area. A farmer has 200 feet of linear fence to enclose a pen. He wishes to use the riverbank as one side of the pen along which he will need no fence. I should say enclose a rectangular pen. He wishes to use the riverbank as one side of the pen along which he will need no fence. A. What is the maximum area he can enclose? B. What are the dimensions of the pen? And C. If each animal in the pen needs 25 square feet of room, how many animals will fit in the pen? Cruelty-free. It's cruelty-free. We're giving him some space, 25 square feet. It's not very big. That's less than 6 feet by 6 feet. But, you know, if you're farming earthworms, that's a lot of room. So we're trying to sustain our earthworm farm, and we're giving them all lots of room. Okay. So the solution begins here with actually drawing a picture. So let's talk about that. Solution. This might be the most critical part. Step 1. Draw and label a diagram. Before we go any further, I'd just like to say that these two applications that we're spending so much time on, you will see something similar on your exam. You will see a business application that involves quadratics, and you will see a geometry problem like this that involves quadratics. So please pay attention to these applications. Draw and label a diagram. So let's see here. A river runs through it, right? Okay, let's see. Here's our river on a relatively straight bank. And what we're going to do is we're going to enclose a rectangular pen, but we're not going to use any fencing along the river. Gosh, come on. Okay, so this is our pen. Now what we need to do is we need to label it. And if I ask you a question like how wide is it and how tall is it or how deep is it, you have to answer those questions as honestly as you can if you want to make it through these word problems and you're kind of scared of this kind of thing. To answer the question honestly, how wide is it? How long is it? The answer to that question is, I don't know. And that's what's called a variable. And even though we're supposed to label our diagram, it's okay to label the things that you don't know. I have no idea how wide it is, but I also have no idea how deep it is, and I do not expect it to be necessarily as deep as it is wide. I said a rectangular pen, not a square pen. And so we have dimensions X by Y are our dimensions. So the dimensions are X by Y feet each, or X feet by Y feet. Now we're told two pieces of information. This next thing is what I call the primary equation. So if you've done this kind of thing before and you remember it from Math 127, I'm trying to lay this out for you like you've done this before. So please pay attention because you may have not been taught to do these problems this way. The primary equation is the equation of the quantity you wish to maximize or minimize. So in this particular problem, we're supposed to find what is the maximum area that we can enclose. So for here, we want max area. So that means area is our primary equation. Now in this particular case for our pen, even though it's missing a side, you don't use that missing side necessarily to calculate the area. The area is the product of the dimensions. It's X by Y, so that's easy enough, right? This area is X by Y. Even though it's missing the other side, whether that side is there or not, it still has the same area. So here our area is X times Y, but here's the problem. This has two variables, X and Y. And if we're going to solve this problem, we need to reduce this down to one variable. We only want one variable. And usually students prefer X. So what we need is not the primary equation, but what's called the secondary equation. And this is typically the other info in the problem that relates the variables, in this case, X and Y, to a constant. So what am I talking about? Well, we know that we want a rectangular pen. We know that we're not using fence along one side, but what's the other piece of information that they gave us in the problem that I haven't used yet? Well, the farmer has 200 feet of linear fence. That's our secondary equation. So what does that mean? Well, it means that this bit of fence, X, plus this bit of X, or fence, this bit of fence, Y, plus this bit of fence, X, plus this bit of fence, Y, is only 200 feet. This is the perimeter of fence. That's our restraint. Our secondary equation is always related to our constraint or our restriction. Now, that is going to help because we can now use our second equation to eliminate a variable from the first equation, the primary equation. That is to say, so step 3, rewrite your primary equation as a function of one variable. And I don't care if it's X or Y, but you got to pick one. So A is equal to XY, and 200 is equal to X plus 2Y. So this means then, let's see, X is easiest enough to solve for. X is 200 minus 2Y, which can be substituted in here, and that means A, now as a function of Y, is 200 minus 2Y times Y, which is 200Y minus 2Y squared. And this is a parabola. It's quadratic. And we should be able to beat up on this and use it to answer the question. So we can graph this really quick, or we can find out some information about it. If I rewrite this, the area is negative 2Y squared plus 200Y. So be careful here. Y is acting like X and A is acting like Y. So if I graph this, oops, this isn't going to be a graph of X versus Y. It's going to be a graph of the Y dimension versus the area. That's what I have here. A is a function of Y. And I can tell you that the vertex H is negative B over 2A, which is negative 200 over 2 times negative 2, which is 200 over 4, which is 50. And so at 50 feet, we're going to get a maximum area. The K value is A at 50, which is negative 2 times 50 squared plus 200 times 50, which is negative 2 times 2500 plus 10,000, which is 10,000 minus 5,000, which is 5,000. And so that is my K value. And this is the vertex, 50, 5,000. And what that means is our graph of our parabola for our area of the enclosed fence, we will have a max area enclosed when Y is equal to 50 feet. And that area will be 5,000 square feet. So to answer part A, you guys like to part A? Yeah, man. Let's grab these questions and answer them. Max area enclosed is 5,000 square feet. And then it says, what are the dimensions of the pen? Well, the dimensions are X and Y, and we know that Y is 50 feet. Now, you can do this one of two ways, but if we use our secondary equation, or you can use basic geometry here, our pen was Y by X by Y. And if this is 50, this is 50, and this is X, and we know that 200 is equal to X plus 2Y. So 200 is equal to X plus 2 times 50. So X is equal to 100 feet. So the dimensions are 100 feet long by 50 feet deep, or 50 feet wide, or 100 feet by 50 feet, or X equals 100, Y equals 50. That's probably the best way for you guys to describe it, though. Just give me the X and Y values. And then finally, if each animal in the pen needs 25 square feet of room, how many animals will fit in the pen? Well, we have 5,000 square feet, and each animal needs 25 square feet of room. And so that is 200 animals will fit in the pen.